What if early membranes were a bit leaky, like these papers suggest? Maybe the first cells had holes in them that were just big enough to let good things in and keep the bad stuff out, somehow finding a good balance to maintain homeostasis. Unfortunately, that won't work. All existing cell membranes need to let big things in, while at the same time keeping small things out. In other words, they have conflicting requirements. All cells harness their energy by pumping protons out and very carefully letting them back in to spin these proton turbines, like a hydroelectric power plant. And protons are teensy tiny. To give you a sense of scale, if a proton were the size of a housefly, then a bit that the cell would need to let in, like this amino acid histidine, would be roughly the size of the country of Monaco. And the smallest known cells would be roughly Sweden-sized. Those are the approximate scales that we're working with. Basically, Sweden would need to keep houseflies out, while at the same time letting the Monaco-sized things in. If the membrane let too many fly-sized protons slip in, the cell would die. So the membrane has to be tight enough to not let these teensy-weensy protons in, but also porous enough to be able to let these relatively gigantic things come right on in. These conflicting requirements of the membrane are a real head-scratcher. Fun fact, at any given time, a cell is generating roughly the same voltage per meter across its membrane as a bolt of lightning. Another conflicting requirement is that cells have to let water in, but if water was just allowed to pour in willy-nilly, so would those sneaky tiny little protons, and this would drain the cell's battery, so to speak, and the cell would, again, die. Thankfully, cells have specialized doors called aquaporins. They work sort of like an airlock in our space house by safely letting things in without destroying the nice environment inside. The aquaporin lets water molecules in single file, but that still wouldn't be enough to stop the protons from sneaking in and killing the cell, because the water acts sort of like a wire, conducting the protons along itself. So the aquaporin also rotates each water molecule by 90 degrees, flipping them around and eliminating its ability to conduct protons for just long enough to safely let the water inside. Every cell has tons of these incredibly specialized doors. The simplest known free-living lifeform is a single-celled guy called Mycoplasma genitalium, but it has thousands of specialized doors composed of over 100 different proteins that operate within the cell membrane. So even the simplest cell has an extraordinarily complex membrane, an active, selectively permeable boundary that allows and often forces exactly the right things in and out to maintain homeostasis. A perfect environment inside the cell, despite wildly varying conditions outside. Leaky membranes and tight membranes would both kill the cell. The membrane had to be extremely complex from the very beginning, or life could never begin.